Right, now that we have created both the description of the Java applet and the modeling of the physics, now we will go on to the view which describes how the Java applet will look like. Okay, so at this point we have variables x position, v for velocity, and t for time. So how are we going to represent this graphically? We click on view, right, and the first thing we need is a window to demonstrate the motion of the falling ball. So I'm going to come to this interface on the right hand side, choose drawing frame, click. You can see a magic wand appears. We move it over to the simulation view, click, and you can see by default it creates a whole group of items, right, that are represented on the left hand side window here. So this drawing frame represents this red box, right? This drawing panel represents the drawing inside the red box. This shape 2D represents the ball, right? By default they inserted a circular shape, right? So for ease of understanding, I'm going to right click on it and give it a different name, ball. Okay, so thereafter I will know that this ball represents this, right? Okay, so I'm going to set the properties of the ball. So I double click. Let's do that again, right? So you can see that the ball's position x, y, its size can all be specified. So since this is Java applet involves only vertical motion, I can set the position, the x position, the horizontal position to be simply 0. It doesn't change at all for the whole simulation. Position y, on the other hand, represents the vertical position, and if you look at the model, we have x to represent the position. So I'm going to link the position of ball right here, the vertical position, plus position y, to the variable that we specified earlier, right? You can see that suddenly the blue ball in this window has disappeared, right? That is because the window is too small, right? So the ball is actually outside the window, above it, right? So if you click on the drawing panel, you can see that its size, the vertical size, is from -1, right, meters to maximum of 1.0 meters, and the initial position of our ball, we set it to 2 meters. So the ball is actually currently not in view, right? So how to correct for this? One way is, of course, to set the ball at a lower height, right? That is the simpler way, right? So for example, if I set this to 0.8, right, you can see that the ball has come into view, right? Another way is to change the size of the window, right? Let's just do that also to demonstrate. So we go back to the view to describe the visual properties of this applet. Now I'm going to click on the drawing frame, right? You can see down here the size is now 300 by 300 pixels, right? So I can set it to a bigger size, maybe 400 by 400. Oh dear, that doesn't really help. Okay, let's set to 300 by 300 again. Okay, so you can see that this drawing frame specifies the actual size of the window. Okay, drawing panel, on the other hand, will specify the dimensions of the actual drawing inside the frame. Okay, so I'm going to set the drawing panel maximum position to -2. Sorry, minimum to -2 and maximum to +2. Right, so you can see the ball has become distorted in shape, right? But you get the picture, right? By resizing the drawing panel, you can actually control the view, right? The scope of the view, right? So I'm going to revert back to the original setting, So now the ball is positioned at x equals to 0.8 meters, which is here. Okay, right, so we are actually ready to run, right, this simple program. So let's save that. Okay, and let's try running it. Click on the green arrow here, run simulation, run. The program compiles it and sets it going, and it doesn't work. That's wrong. Okay. So what have we missed? Okay, position X. Okay. Somehow just now the V wasn't set. Okay, can. Right. Okay, right. So everything is now fixed. Once again, save it and then click on run. The program compiles it, and there you go. Right, now we have a working applet. Okay, so press the red arrow to stop the simulation, and there we have it. So save it